Welcome back to class, guys. Now we're going to talk about the remote sensing. It's part of mapping our world, so let's dive in. So the key questions for this unit, we're going to focus on what is remote sensing? What are the different types? How are satellites and sonar used to map the Earth's surface? What is GPS and how does it work? And what is GIS and how is it going to relate to our future? So remote sensing is the process of gathering data about the Earth using instruments. And these instruments can be on satellites, they can be on planes, they can be on ships, but the whole purpose is usually to make some kind of map. So it's just gathering data using instruments on some type of vehicle to create a map. The first type that we're going to talk about is the Landsat satellite. This is remote sensing using satellites. So the satellites that are orbiting the Earth are going to measure the heat and the light and the ultraviolet that are coming back off of the Earth and going out into space. And what's going to happen is a computer is going to convert these readings into an image. So we're going to study things like pollution. We're going to look at how the tectonic plates of the Earth are going to move and change, how the surface of the Earth changes, how we can help with natural disasters, and so much more. So here are some pictures of a Landsat satellite. Very cool. So here's a really interesting example. When I talked about how it can help with natural disasters, the image on the top left is of Lake Pontchartrain, right outside of New Orleans. It's a huge lake. This is it before Hurricane Katrina, and this is the lake after Hurricane Katrina. It's kind of hard to see, but you have tons of flooding all over the area. So you can actually see how much a disaster has affected a certain area and be able to plan how to fix it from there. The second type is the OSTM, or JSON-2 satellite. OSTM stands for Ocean Surface Topography Mission. This satellite is going to use radar. It's not going to be the same as the previous one. And it's going to measure and map the sea surface. So this one's looking at one very specific thing. It only wants to know what's going on to the surface of the ocean. And this is a very, very, very accurate satellite. So what could we use this technology for? Why do we care about the sea surface? We use it to measure, to monitor changes in the surface of the ocean, because the more heat that the ocean captures, the more it's going to rise, the more it's going to expand. So if the ocean is getting warmer, it's going to be taller than it was before. We can use this to predict changes, to forecast the weather, especially things like El Nino. The pictures on the bottom are a picture before, or actually both of them are the El Nino that happened in '97 and the El Nino that happened in 2015. And you can see how there's a really big ocean surface rise in this area where it's red. So all of this is where the ocean is getting taller than before because it's getting warmer, and it can predict that an El Nino is going to occur and that the west coast of the United States is going to get a lot of rain. The next type is the C-beam. Now, this is a little bit different because it's used to map the ocean floor, not the ocean surface. So we want to know what's going on to the top, but we also want to see what's underneath. And this is also going to use sonar technology, which is just reflected sound waves. It's kind of like echolocation that bats and dolphins use. So what could we use this type of technology for? Well, it's good for deep sea drilling, for people who study underwater volcanoes, oceanographers, archaeologists who are looking at sunken ships and things like that. And fishermen often use it to find fish better because you can actually see the fish underneath the water with this. So this one's pretty unique in that it has a lot of different applications. The next type is GPS, the Global Positioning System. I hope you guys know this one because we use it almost every day, I bet. So this is going to allow our users to find their actual position on the Earth, their actual latitude and longitude, and it allows us to navigate the world better. This one works by using many different satellites, and they all are locking onto your signal, and they can tell you where you are. So often it's a network of 24 orbiting satellites, and to use their data you have to have a special receiver, and normally now that's in our phone. So it's going to calculate our position and our elevation, so it can say where we are and how high we are on the Earth. So GPS is used for navigation, obviously. We use it every day. But it started out as something for the military. They wanted to be able to plan their campaigns easier, so they wanted a way to track their troop movement all the time. Now it's moved on to ships and airplanes and personal use. Hikers use it when they're traveling in areas that have unmarked areas. There's no roads, no landmarks. But we're actually starting to use it to detect things like earthquakes or to even make maps. It's pretty fascinating what we're starting to be able to use this for. The last thing that we're going to talk about is the Geographic Information System, GIS. It's just a combination of many different types of maps that we layer on top of each other to make one kind of big hardcore map. And we use it in many different scientific disciplines. So it's updated all the time with new information, which you can't really do with a traditional map. And that's because this is all kind of built in on those computers. So once you have it stored in there, you just add new information and the map automatically updates itself. So this is going to be the best way to create one comprehensive map of an entire area. You can see the surface, you can see the geology, you can see the surface of the ocean height. You can see all of this stuff all at once. All right, that was a pretty short one. So for remote sensing, let's go over what we just talked about. It's modern day cartography, modern day map making, and we use it to gather information. These are special sensors that are on ships and planes and satellites, and they're going to take information and send it back to us. So the first type that we talked about was a Landsat satellite, and they record images using electromagnetic radiation like light. OSTM used radar and satellites to measure the height of the sea surface, while the C-beam used sonar from ships to map the sea floor. GPS used a network of tons of satellites to give you a very accurate position on the Earth. And GIS is going to be the future of mapping. It combines all the different types of maps into one, and a computer integrates it into one seamless map that can update in real time. So these maps are all used by scientists, city planners, and even the everyday person. They're very important. If you guys didn't understand anything or if you have any questions, please write those down and we'll talk about them in our next class. Talk to you later.